Now welcome back to Apostle 1 tutorial. Yes, Apostle 1 tutorial. Now today too, we are coming to continue with our trigonometry. Yes, I'm here to break it down for you to understand. Make sure you follow me closely. Listen to every word I'm going to say. Yes, if you don't understand it, let me know in the comment section. Yes, if you don't understand, let me know in the comment section. Now, in our previous video, I talked about the introduction to trigonometry. Then we went through the Pythagoras theorem, because Pythagoras theorem, rectangle triangle, form the important part of the trigonometry. Yes, it forms important part of trigonometry. Yes, so now let's move on. I'm coming to talk about the basic trigonometry ratio. Yes, so we have the basic trig ratio. Now we have three main basic trig ratio, of which all other ratios trig were derived from. Yes, we have the main one, the trig. We have the main one. The first one is called the sine, the second one is called the cosine, and the third one is called the tangent. Yes, and this trig ratio links with the side, both the side and the angle of a rectangle triangle. So this one is not like the Pythagoras theorem. This one will help us to be able to solve for the side including the angles. Yes, it will help us to solve for the side including the angles of a right angle triangle. Yes, so it has a particular formula that links the side to the angles of a right angle triangle. Is for only right angle triangle or orthogonal triangle, which means a triangle with one of its angle being 90 degrees. Yes. Now, so let's see the three basic trig ratios. We have three basic trig ratios. Now we have the first one called the sine. We have the cosine, and then we have the tangent. Now in the form of a graph form, when you draw a graph for the sine graph, the sine graph, you start from here. If here is 1 and here is -1, it starts maximum of 1 and then minimum of 1. It starts from here, move up, comes down, and then moves like that. This one is the nature of the sine graph. And then the nature of the cosine graph, that one too has a maximum of 1 and then the minimum of -1. The cosine graph also starts from here, moves down, goes up, moves down to 1, goes up to 1, the minimum and then the maximum to be 1 in that order. Now the tangent graph goes like this. The tangent graph is like this. Now, as time goes on, we learn more about this. You see, the nature of the graph looks like how the sea, the waves of a sea. You see, yeah, very applicable in real life situation. Now, these are the three basic trig ratios. The tangent, yes. Now, we have a short form of it. Now, when we talk about the sine, we use the first three letters. This is not sin, it is sine, yes. And this one is the first three letter, that is cos. This one we use the first three letter, which is called the tan. So when we consider a right angle triangle, we're going to consider an angle inside a triangle. Then we have sine of the angle, cosine of the angle, and then the tangent of the angle. Yes. Now, so let's see. So as I was saying, these trig ratios links with the size and the angle of a right angle triangle. Yes. Using a particular formula called SOH. Say SOH. SOH and then TOA. SOH. Where the first letter here, the S, is called the sine. The first letter here is the cosine or the cos. the t here is the tangent or the tan. Don't forget, I'm coming to use the shortcut form, not the real one. Yes. Now, here is O and H, here is A and H, O and then A. This last two letters, the last two letters represent the side of a right angle triangle. The side of a right angle triangle, where this one being the hypotenuse, here being the opposite, and then here be the adjacent. So the last two letters represent the sides of the triangle. So what does it mean? This sine, cosine, and then tan is linking the angles with the side of the right angle triangle. Yes, follow me closely. Follow me closely. Now, so I'm coming to use something called the Circle Theorem. Now, so the three basic ratios, we have 1. If we have a rectangle triangle like this, here is 90 degrees, where the angle here is theta. The angle here is theta. Now, let me consider here to be A, B, and then C. Let AB be equal to X, this one be equal to Y, and I'm going to use R for the hypotenuse. Yes. So what does it mean? Here becomes the hypotenuse. This is the angle theta. So as we explained some time ago in our previous video, now when we consider the angle theta here, this angle is facing this particular side. You understand? It is facing this side. So since it is facing this side, here becomes the opposite. It is the side opposite to the angle, so here becomes our opposite. And then, as we know already, the 90 degrees is facing here. The 90 degrees is facing here. Where the 90 degrees faces is always the hypotenuse. Hypotenuse. And then here becomes our adjacent. Here becomes our adjacent in that order. Yes. Now, when the angle is at C, when the angle is at C, when the angle is here, when the angle is here, let's say the angle is here, 90 degrees is here, identify your 90 degree first. Now, this 90 degrees is facing this particular side, so here becomes a hypotenuse. Yes. Then you come and identify your opposite first. The last side becomes the adjacent. Now this is the angle here theta is facing here, so this side becomes our opposite, and then here becomes our adjacent. Look at where the angle is facing. Where the angle is facing becomes your opposite or the adjacent in that order. Yes, follow me closely. Yeah. Now, let me consider this rectangle triangle. Let me consider this right angle triangle. Now, let me find the sine. The sine, the short form is sine. So, I'm going to consider sine of the angle. The angle is theta. The second one is the cosine. The cosine. The cosine is the same as the first letter words is cos. So cos of the angle here is theta. Then the last one, the 3, is called the tangent. The tangent. The tangent. So the first letter words is tan. So you're going to get tan of the angle theta. What is the formula that is linking the sine, cosine, and then the tangent? Is what we call the short form is Circle Theorem. Circle Theorem, where the S represents the sine. So anytime I'm talking about the sine, I have to use the so. I have to use the so. Yes, it is a formula on its own. So keep this formula very well. Now, it is provable, but I will not get time to prove that. Maybe in our later video, I'll prove this. Now, the sine is opposite over hypotenuse. So, when I take the first letter sine, it is the next letter O divided by H. That's why we said it's a ratio. Ratio means division. trigonometry ratio, it is division. Now, when we take the cos, the C, anytime you have the cos, C is the trig ratio, cos. It is the adjacent over the hypotenuse. Now, when we consider the last T, the T is the O divided by. So, it means that when I consider the first letters, they are the trig ratios. The second and third letters are the sides of a rectangle triangle, where the O is the opposite, the H is the hypotenuse, the A is the adjacent. When we consider the C, the cos, the A is the adjacent, and then the H is the hypotenuse. When I consider tan, the T is the tangent, the O is the opposite, and then the A is the adjacent. And how the formula goes? The formula is when you take the sine, the O divided by H, opposite divided by the hypotenuse. Yes, that order. Now let's look at this one. When we consider the sine is opposite over hypotenuse. Then, so I'm going to write a formula. So you take this particular one. Which one is the hypotenuse? The hypotenuse is here. It is BC, and BC is R. We have AB, AB is X. We have AC, AC is Y. So which one is the opposite? The opposite is where the angle is facing. This is the angle we are taking into consideration. Now this angle is facing the line AC. So it becomes AC, that's the opposite, divided by the hypotenuse. What's the hypotenuse? Is the BC. The hypotenuse is BC. What is AC? AC is the same as Y. The BC is the same as X. So the formula is Y over X. That is where Y is the opposite to the angle, and then the X is the hypotenuse. The hypotenuse is the R. Yeah. Hypotenuse is the R, where the hypotenuse R of the rectangle triangle. Now when we consider the cosine is CAH, and CAH is adjacent over hypotenuse. So when you consider the adjacent here is AB. Adjacent is AB divided by the hypotenuse, which is BC. Hypotenuse BC. Now what is AB? AB is X. And then BC is what? BC is R. So which means the cosine is X over R. That is adjacent over hypotenuse. Now when I consider the tangent is TOA. That is opposite over adjacent. What is the opposite? The opposite is AC. The angle is opposite to this side, AC, divided by adjacent. Adjacent is AB. So this shall be adjacent is A and then B. What is AC? AC is Y, and then AB is what? X. Yes. Follow me closely. Follow me closely. Now, so we have 1, 2, 3, 4. Now let me talk about another formula for the tangent. Another formula for tangent. So let me label it as 4. Another formula for tangent. Let me find the ratio of the sine and then the cosine. Sine theta divided by cos theta. What will it give us? What are we going to get for sine theta over cos theta? We are coming to prove tan theta. Now, sine theta over cos theta, what is sine? Sine is y over r. So we have sine to be y over r divided by the cosine. Cosine is x over r. This is the cosine. Cos is x over r. So we have x over r. Now let's apply our simple mathematical operation in fraction. So we are going to have y over r. We change this one to multiplication. Then we turn this one upside down. We reciprocate the second fraction. S over r. Now this r and this r will go off. We're going to get y over x. Y over x. Now what is y over x? Look at something. This y over s is the same as y over x here. This y over s is sine theta over cos theta. And then this y over x here is also tan. So what does it mean? Anytime we have sine theta over cos theta, it is the same as y over x, and y over x is the same as tan theta. So therefore I can conclude that sine theta over cos theta will also give us tan theta. And that is another formula for the tan theta. So tan theta, anytime you see tan theta, is the same as sine theta over cos theta. Tan theta is the same as sine theta over cos what? Theta. Yes. I will teach you how to use this thing very well. Yes. Now let's move on. Make your own notes as I'm teaching. Now, I'm going to talk about another trig ratios. That is reciprocal of the trig ratios. So let's see. Now, so I'm going to continue. Now, so we ended the fourth one, which is the tan, which is equal to sine theta over cos theta. Now, the reciprocal of the trig ratio is when we turn the trig ratios upside down. If I have sine of any angle, if I turn this one upside down, reciprocal of this one the same as 1 over sine theta. That is a reciprocal, and we have a name for this particular trig ratio. Yes, and that is what I'm coming to talk about. So we have other three. So let me continue. 5. We have another one called the secant. The short form for the secant is the first letter, which is sec. So sec of any angle theta. The sec is the same as 1 of the cosine. So cos theta. So sec theta is equal to reciprocal of the cos theta. Then the next one is says we have cosecant. Now this cosecant can also be shortened as cosec of the angle theta. Some of them write it like this, cosec. Any of them is correct. When you go and meet cosec like this, CSC is correct. When you go and meet it like this too, is also correct. But I'm coming to make use of this one, not this. I'm coming to use this one, cosec. Now, cosec is also the reciprocal of the sine. So the reciprocal of the sine will give you the cosec. The last one is cotangent. So as the name implies, the first letter word is cot. So cot of the angle theta. Now the cotangent is also the same as what? 1 over reciprocal of the tan theta. So these are the reciprocals we have. So sometimes you're going to see something like sec. You're going to see something like cosec. You're going to see something like cot. When you see cot, you have to know the same as 1 over tan. When you see cosec, the same as 1 over sine. If you see secant, the same as 1 over cos. They are the reciprocal. Now let me deduce this one too. Let me deduce this one to get another formula for this. Yes, another formula for the cot. And you're supposed to keep everything in your head. So let's see. Now, cot of angle theta is equal to 1 over tan theta. But looking at the point number 4, we got to know that we go to know that our tan theta is now sine theta over cos theta, right? So let's substitute here. It means my cos theta will be equal to 1 divided by tan theta, right? 1 divided by tan theta. But what is tan theta? Tan theta is sine theta all over cos theta. So I am deducing another formula for this. So what are you going to do? We apply our mathematical operation. We have 1 times what? This one changes to multiplication. Then we reciprocate the second fraction. We turn this one upside down. So to give us what? Cos theta divided by sine theta. So finally 1 times cos theta over sine theta will give us cos theta divided by sine theta. I hope it is clear. I hope it is very, very clear. This is very simple. It is very, very simple. So what did I do? I talked about the basic trig ratios. And what are the basic trig ratios? The cosine, the sine, and then the tangent. Yes, the tangent. And then we go to know that the cosine is CAH, which is adjacent to our hypotenuse. The sine is, so keep it in your head, so is opposite of our adjacent hypotenuse. And then the TOA, that is the tangent, is equal to opposite of what? The adjacent. And what again? We deduce another formula for tan in relation to the sine and then the cosine. Then we go to know that the tan is equal to what? Sine theta over cos theta. Now, the reciprocal of the sine will give you, when you turn the sine upside down, it will give you the cosec, that is cosecant, cosec of any angle. Now, when you turn the cos upside down, it will give you the secant, that is the sec. When you turn the tangent upside down, you're going to get what? The cotangent, that is the cot. We call the reciprocal of the trig ratios. Yes, we have more of the trig functions. We have hyperbolic functions, but we are limited to this per the YX syllabus. Yes. Now we are deducing the cotangent. Yes, cotangent. Cotangent is 1 over tan. By the tan, this is my sine theta over cos theta. So substitute here, the same as 1 divided by sine theta over cos theta, because sine theta over cos theta is the same as the tan. Now, applying your mathematical symbol, mathematical operations, we have 1 division to multiplication. You turn the second fraction upside down when we apply our knowledge in fractions. Yes. Now, 1 times cos theta over sine theta will give us cos theta over sine theta. It means another formula for cos theta is the same as cos theta over sine theta. Cos theta over sine theta. So you have to keep this thing in your head as trigonometry is concerned. Yes. Actually, now I'm going to explain how you can make use of these things. Yes, we can use this one to solve plenty questions. I'm going to start from here and then solve many questions on it. Now I'm going to solve some few questions, and after I'll give you some questions for you to go and try. Send me the answers on WhatsApp. Yes, send me the answers on WhatsApp. I'm going to build your understanding on how to use the SOH. How to use the SOH in relation to this. Now let's move on. Let's solve this question. Now, let me consider a rectangle, triangle, then we try to figure out our cos theta and sine theta and those things. Now, question 1. So we are still applying our SOH. Don't forget this. That is the term we are using. SOH. Make sure you like the video and then you share to your friends. Your comment is very important. Yes. Now, let's see. Now, let me consider this one. A. I have a rectangle triangle like this. Now this is my rectangle triangle. It's a rectangle triangle. Now this one is 12. This one is 15. And then let's say this side is what? Let's say this side is 5. This side is 5. This side is 5. How are we going to find our sine, cosine, and the rest? Okay, so find I. I'm considering the angle here. The angle, we can use anything to represent the angle. I'm using theta to represent the angle. Now we are looking for sine theta. We are going to look for cos theta. We are going to look for tan theta. I want to solve for sec theta. Then let's solve for cot theta. Let me end here. Now solution. Now what is our sine theta? We have to use our SOH. Sine theta came from the word so, which is opposite over hypotenuse. Opposite over hypotenuse. So with this particular triangle, here is 90 degrees. 90 degrees is facing this side. 90 degrees is facing this side. So here becomes our hypotenuse. And then where is our opposite? Opposite, this is the angle theta. This angle is facing this particular side, 5. So the 5 here is the opposite. And then the down here becomes the adjacent. So the sine is so, and so means opposite over hypotenuse. What is the opposite? The opposite is 5 over hypotenuse. Hypotenuse is 15. Now 5 going to this side 1, 5 going to 15 3 times. So the answer is 1 out of 3. You have to break it down at least if you can. Now I cos theta. Cos is CAH. And what is CAH? CAH is adjacent over hypotenuse. What is the adjacent? Adjacent is this one, that is the 12, divided by the hypotenuse, that is the 15. Now what number can go into 12 at the same time 15? What number can go into 12 at the same time 15? 3 can go into 12 4 times, 3 can go into 15 5 times. So the answer is 4 out of 5. Now the third one, so it is just simple like that. The third one is tan theta. Tan theta. Now tan is TOA. TOA is opposite over adjacent. Opposite over adjacent. What is the opposite? The opposite is 5. And what is the adjacent? The adjacent is 12. No number can go into 5 and 12, so we leave it like that. Now you can also use the formula tan theta is equals to sine theta over cos theta. So when we divide this one and this one, sine theta is 1 out of 3 divided by cos theta, which is 4 out of 5. So when we continue to be 1 out of 3 multiplying 5 out of 4. So this one gives us 1 times 5 is 5, 3 times 4 is 12. We are getting the same thing, 5 out of 12. And that is our tan theta, if you want to apply the formula. Yes. Now let's move to I. We have our sec theta. Now what is our sec theta? What is sec? Sec theta. Sec is 1 over cos theta. Don't forget, sec is 1 over cos theta. So we have one is reciprocal. So 1 over cos theta. So it means it is 1 divided by cos theta. What is cos theta? Cos theta is 4 divided by 5. So 1 divided by cos theta. We have 1 divided by cos theta, which is 4 out of 5. So how do we solve this one? it will be 1 times 5 out of 4, which will give us 5 divided by 4. Now the last one is when we are supposed to solve for cot theta. Don't forget that previously we said cot theta is the same as what? Cos theta divided by sine theta. Yes, that's the formula we had from our previous deduction. Now we can also apply this. What is cos theta? Cot theta is the same as 1 over tan theta. So we have 1 divided by tan theta. What is tan theta? Tan theta is 5 out of 12. So we have 5 out of 12, which will give us 12 divided by 5. 12 divided by 5. So this is how we can make use of this particular trigonometry ratios. Yes, so CAH. Now let's take the second question and let's see how it works. Let's take a second question. Now B, let's consider this particular rectangle triangle. Here is 90 degrees. This side is 5. Here is 4. And then we are supposed to find one I cot. I want to consider the angle to be A. Now, so we are going to have cot A, cot of the angle A. Now, it's not if they're going to use the angle to be theta, they can change it, they can make the angle X or anything, yes. Now, let's solve for sec A, and then I. Let's solve for cosec of the angle A. Now, this one, I'm going to look for cosec square. I'm going to look for cosec square. Cosec square. Cosec. Now, when we have sine square theta, we don't write it like sine square theta is the same as we have the sine theta, and then it is all squared. This and this they are the same, but we don't write it like this. We write it like sine square theta. So cos square theta, sec square theta, cot square theta in that order. Yes. Now, so let's see how I'm going to solve this one. We have a rectangle triangle like this, and we are supposed to find cot theta, cot A. We have sec A, cosec square A, cosec square A. How are we going to find? These are all reciprocals. Yes, they are all reciprocals. So we need to do a lot of work. We know that the cot is the same as 1 over tan. The sec is the same as 1 over cos. The cosec is the same as 1 over sine. Yes. So before we can solve this one, we have to look for the sine, we have to look for the cosine, we have to look for the tan before we can solve this. So let's begin. But there is a problem here. Look at the question. If you look at this one, this 90 degrees is facing the 5. So here becomes the hypotenuse. The angle here is A. This angle is facing this particular side. So here becomes the opposite. Then here becomes the what? The adjacent. The adjacent is not known. The adjacent is known. So first you have to look for the adjacent using the Pythagoras theorem. We have to look for the adjacent using the Pythagoras theorem. So let's see. So this is our triangle. 4, 5, 90 degrees. The angle here is A. I'm going to use a letter to represent. I'm going to use X to represent here. Yes. So from our Pythagoras theorem, hypotenuse square is equals to opposite square plus adjacent square. So hypotenuse is 5. So 5 squared. What is the opposite? The opposite is 4. So 4 squared. The adjacent is X. So we have X squared. 5 squared is 25. 4 squared is 16 plus s squared. So we have to group like terms. So we're going to have our 25. It is positive when of course become negative. So minus 16 is equal to s squared. So 25 minus 16 will give us 9 squared. And then what will be our s? We need to square root both sides. So our s will be equal to 3. We are not going to use plus or minus because this one you're talking about the length from here to here, and then we don't have negative length. Yes, we don't have negative length. So directly as time goes on, I'll add more explanation to this one where we can introduce plus or minus. We introduce plus or minus if it is falling in a different quadrant. We will talk about it, don't worry. Now, so we have the x to be 3. Now, so because of that, we can find our sine theta, sine A. What is our sine A? Sine is opposite. So, sine is so, that is opposite over hypotenuse. The opposite is 4. The hypotenuse is 5. Now, what will be our cos A? Cos of the angle A. The cos is adjacent over hypotenuse. So adjacent is 3, hypotenuse is 5. So we have 3 divided by 5. And then the last one is tangent, tan of A. Tan is TOA, opposite over adjacent. The opposite is 4. And then the adjacent is 3. Yes, adjacent is 3. Yes, at this time you have to be able to identify all the parts of a rectangle triangle. Yes. Now let's see. The first one is we are supposed to solve for cot A. What is cot? Cot is 1 over tan A. It's a reciprocal, it's the same as 1 over tan. Yes. So we're going to get 1 divided by 4 out of 3, which will give us 3 out of 4. As simple as ABC. You reciprocate this one, then you are done. Now let's come to II. We are looking for sec A. What is sec A? So you see, sometimes you're supposed to solve for the missing side before you be able to complete whatever that you're supposed to solve. Now let's see sec A. What is sec A? Sec is 1 over cos A. So we have 1 divided by cos A. What is cos A? Cos A is the cos here is 3 out of 5. So we have divided by 3 out of 5, which will give us 5 over 3. Now the last one, I is cosec. Now let me look for cosec first. Cosec is 1 over sine. It means that when we square this one, we're supposed to square this one too. It's very simple. Now, so we have 1 over 1 divided by sine. What is sine? Sine is 4 out of 5. 4 out of 5. It's very simple. So, which will give us what? 5 over 4. Now, what we are looking for is the cosec squared. Cosec squared. Let me clean this one. So we have cosec squared A, which means that we are supposed to square this one. The cosec A is 5 out of 4. Is 5 out of 4 squared. So I have to square this one. Now what is 5 squared? Is 25. The square will affect the 4. It is 4 squared. 4 squared is 16. So cosec squared is 25 out of 16. I'm going to give you a simple question for you to try it. Yes, try it and send the answer to me on WhatsApp. Yes, give me the solution on WhatsApp. So copy this one and then try this. Now see you. Now question 1. Question 1, we have a diagram like this. So I'm going to consider a diagram like this. This angle is A. The hypotenuse here is root 18. Here is 2, and this side is 3. Find I sine A I cos square A I cot A. Then question 2, I'm going to give another triangle. So we have right angle triangle like this. 90 degrees is here. Now we have here to be 17 and this side to be 15. Now let me consider my angle to be here. The angle is B. So you are going to find I. You're going to find I cosec of B. We are going to find II sec of B, and then I. We are going to find tan B. So this is the question for today. Make sure you subscribe to the channel. If you don't understand anything, let me know in the comment section. See you another time. Share the video to as many students that you know. Share it to all the friends that you know. See you another time. Bye bye.